This lesson will cover Unit 2, Acquisition 5, and our topic for today is the flame test. So based on what we already know about the atom, we know that electrons travel in orbitals based on their energy level. And when we're labeling our model of the atom, we use N to represent the energy level. The farther away an electron is from the nucleus, the higher the energy level. So we talked about that already. Those first 2 points should sound familiar. So let's say this is my atom. We know in the center of the atom we have the nucleus. Again, we use N to represent energy level, so that first energy level closest to the nucleus would be N equals 1, followed by N equals 2, and N equals 3. So as we move away from the nucleus, that energy level is going to increase. The ground state. This is like an electron's home base. It is the lowest possible energy level for an electron. So the lowest energy level, the energy level that an electron starts in, is called its ground state. Well, electrons can absorb energy. And what happens when an electron absorbs energy? It can jump to a higher energy level. So let's say we were to energize an atom, maybe by heating it. What's going to happen is that electron can absorb energy and it's going to jump to a higher energy level. So maybe my electron starts in its ground state N equals 1, and it is going to absorb some energy, and it could jump up to that third energy level. So an example of an electron absorbing energy would be my electron jumping from the first energy level up to the third energy level. Well, now it's no longer in its ground state. Now it's in what we call the excited state. The excited state is the energy level an electron moves to when it absorbs energy. So again, for this example, my ground state would be that first energy level. It absorbs some energy and it moves up to the third energy level. N equals 3 would be its excited state. Well, electrons don't want to stay in this excited state. They want to go back to the ground state. They want to go back to their home base. So what's going to happen is this electron wants to move back down. So during the fall, from the excited state back to the ground state, energy is released. So if it absorbs energy on its way up, when that electron goes back down, that energy needs to be released. And it is released in the form of a photon. A photon is just a packet of light energy. So let's say this electron now falls back down to its ground state. Well, all of that energy that it gained has to go somewhere, and it's going to be released, and it's going to be released in the form of light energy, and we call that a photon. So what happens when we're going to do the flame test is we are going to put certain metal chlorides into a flame. That heat is going to energize the electrons, and they're going to jump from their ground state up to the excited state. When those electrons fall back down, they're going to release the energy in the form of light. Based on the amount of energy that gets absorbed or released, we're going to see different colors. So the larger the jump, the more energy either absorbed or released. If we have a large jump and we're releasing a lot of energy, we are going to see higher frequency light. So you might see like a purple light. That's going to be a higher frequency, more energy. And then just the opposite, the smaller the jump, the less energy absorbed or released. So if we are absorbing and releasing less energy, we might see a lower frequency light, maybe like a red or an orange. The amount of energy emitted determines the color of light seen.